Lesson 8.1b, factoring trinomials when a equals 1. These are the extra examples. So if we have something that looks like this, 4m squared minus 4m minus 8, it may not necessarily look like a is equal to 1, but if you piece back the last lesson where we learn about the greatest common factor, you're going to find that the greatest common factor between all of these happens to be 4. Okay? So if we go and simplify all of these terms by the greatest common factor, then we're able to pull that out, and we can simplify each of these. That can be m squared minus m minus 2. And now inside here we do have a trinomial of a equals 1. Okay. Applying the skills from the last lesson, we're going to look for factors of c, okay, to add up to b. So here the factors of 2 are just 2 times 1. But we need to have the middle term be equal to be a negative. So that means I have to make the 2 a negative number. So 2 plus 1 is equal to negative 1. Right, knowing this, I can break down my trinomial into two binomials. And I have my variable m, that's going to give me m squared. This is a negative c, so we have plus and a minus, and we established that the bigger one has to be the negative, so minus 2 plus 1. And that's how you would factor this. Here's another problem. You can try this on your own. You can pause the video. We have 3r squared plus 21r plus 30. There is a greatest common factor between all of them, and that's going to be 3. So these are all divided by 3. All right, with 3 on the outside, I can rewrite the trinomial as r squared plus 7r plus 10. And now I'm looking for factors of c that add up to the b term, 7. So the factors of 10, we have 10 times 1 and 5 times 2. And I can see that 5 and 2, if I add both of these, that's going to give me 7. So that means I'm going to go with these factors. All right, to set this up, I'm going to split this into two binomials. We have our variable r times r. The c term is positive, so this is going to be plus and plus. And then I just have to place the 5 and the 2 here, here. And because both of these are positive, I can place a 2 here instead. The 5, the order is not going to matter. So this is the factor form. All right, here's another instance where we think we're not able to apply factoring quadratics if we have a cubic polynomial, but in disguise, this is comprised of a quadratic and another x term. Right, all these have an x in common as well as a number. So if I was to pull out the greatest common factor between all of these, right, that would be equal to 2x. That meaning all of these are divisible by 2x. All right? And so placing the 2x on the outside and simplifying, we do get a quadratic trinomial. So x squared minus 14x plus 45. Now, here we have a trinomial of a equals 1. Same thing, we're going to look for factors of c, add up to b. So 45 has 45 times 1 as factors. It has 15 times 3. And we have 9 times 5. Right, the only two that add up to 14 in some way are 9 and 5. And that is if we make both of these negatives. So negative 9 minus 5 is equal to negative 14, all right? So knowing that, we can split this into two binomials where we have x and x. And because the c term, we could have plus and plus, but the b term is negative, so we can have minus and minus as well. So minus 9 and minus 5. Okay, you can try this problem on your own. Pause the video if you like. So same thing here. We have a p in common as well as a number. So my greatest common factor for this problem is going to be 4p. So I'll divide all these by 4p. And that's going to be on the outside now 4p times a quadratic. So p squared plus 3p minus 18. All right, looking at factors of 18, we have 18 times 1, we have 9 times 2, and 6 times 3. In order to get the b term of 3, we can use 6 and 3. If we make 6 positive and subtract 3, that gives us 3, so that we can rewrite the factors as plus 6 and minus 3. So p is our variable, multiply that first. The c term is positive. The c term is negative, so we have a positive and a minus here. And then we make the 6 a positive number and the 3 the minus number. So this is going to be my answer for this problem.